Let's say you have a matrix A where A is 1, 5, 3, 3, right? How would you find the characteristic polynomial of this 2 by 2 matrix? Well, one way would be to find the determinant of A minus lambda I, right? So let's figure this out. So A minus lambda I would be 1 minus lambda, 3 minus lambda, and then 5, 3 remains the same. Then you would find the determinant of this, right? How would you find the determinant of this? Well, it's going to be AD minus BC. A is 1 minus lambda, 3 minus lambda, minus 5 times 3 is 15. Then you got to distribute this out. 3 minus lambda minus 3 lambda plus lambda squared minus 15. Reorganize things. Lambda squared minus 4 lambda minus 12. After all that work, you get this as the characteristic polynomial, right? However, faster way that you could do this would be to use a shortcut. Ways method 2. Well, basically the shortcut says that if you have a 2 by 2 matrix, the characteristic polynomial of A is always going to be equal to lambda squared minus the trace of A minus the trace of A, lambda, and then plus the determinant of A. Now, what is the trace? The trace is basically the sum of the diagonal values. So in this case, it's going to be 1 plus 3. Trace of A is going to be equal to 1 plus 3, which is 4. And what's the determinant of A? It's just determinant of A is going to be AD minus BC, right? Which is going to be um 3 minus 15, which is negative 12. So characteristic polynomial of A is just going to be lambda squared minus the trace, which is 4 lambda, plus the determinant of A, which is negative 12. And we could tell that these two values match. So it is correct, but it is definitely faster to use the second way when you have a 2 by 2 matrix.